Did you all know that Python is actually one of the programming languages used by both Google and YouTube because it is so simple and easy to use? It's a fun language to learn, and we'll learn it. So, today we are going to be dealing with how Python executes its programs, right? And while executing its programs, what are the priorities, what statements are the priorities that Python gives preference to? Okay, so let's start with the what type of statements are there in Python. There are complex statements, there are simple statements, and then there are empty statements. So, complex statements, all of those include the for loop that we use, the if else statements, the if statements, or any type of conditional statements or loop statements that we use. Those are complex statements. Simple statements are just commands that we pass to Python. For example, using simply the print statement or just a simple program without any complex statements like the if else or the for loop or the while loop. Then you come to empty statements. Empty statements is nothing. You can't say that there is an importance of these statements. What this usually just does is that if Python comes across such a statement, then it will just move on to the next statement without giving or paying any heed to the past statement. And the empty statement is denoted by pass. Okay, so it will just execute the next statement without any problems. So, coming on to our complex statements. Now, in our complex statements, we have the if conditional statement. Okay, conditional statements are those statements which are executed or which are only executed when the condition related to them or the condition that is given in that statement is satisfied. For example, we have an if statement that we are using and we say, let's say, we declare x to be 4 and then we say if x mod 2 equal to 0, then print x. This is a very simple Python program and this is our if block. If you remember from our previous video, then blocks are basically a set of Python statements that are included under another statement. Okay, so this is our if block and our if block contains only one statement which is the print x statement. Now, if you remember the modulus operator, it checks or it gives us the remainder. So what basically we are checking over here is if 4 mod 2 or if 4 divided by 2 gives us a remainder of 0, then we'll print x or will not print x. So what would basically happen is that if our condition statements it proves to be true, then printing will occur or else nothing would happen. It won't raise an error, but it won't do anything else. And over here, outside the block, if you say print x, let's say you were taking 5 over here. Okay, there is a difference between this print statement and this print statement. What the difference is? This print statement will only be executed when this condition proves to be true, which it is not, because 5 mod 2 is not equal to 0. Modulus statements also only deals with integers, not floating point numbers. So, because it deals only with integers, 5 mod 2, the remainder would be 1, which is not equal to 0. And since it is not equal to 0, our print statement inside the if block won't be executed. This print statement, however, will be executed and you will only get an output 5. Okay. Then moving on to the if-else conditional statements. Okay. Now, let's say you want to say x equals to 5 and we'll take the same condition if x mod 2 equal to 0, print x, else print number is odd. Okay. Now, in this particular program, what is going to happen is that first Python will check whether this condition is true. As you can see, this condition is not true because 5 mod 2 is not equal to 0, or 5 mod 2 gives us a remainder of 1 which is not equal to 0. So it will skip this statement entirely. It will move on to the else part, and in the else part, it will execute this statement that the number is odd. So our output will be that number is odd. Okay. Now, what would have happened if I had taken 4 over here? If I had taken 4 over here, rather than skipping this statement, this condition would have been proven to be true. This statement would have been executed, and this part would have been null or invalid, or this part wouldn't have been executed at all, because if this condition is true, then it won't move over to this next part. It will execute this statement and the program would be terminated. Then there comes the if-elif conditional statements. They are pretty similar to the if-else statements, but the thing is that elif can only be used with the if conditional statement, and also within an if statement you can use multiple elif statements. For example, let's say you want to use multiple elses. For example, let's say you have a condition x equals to, for example, if I say my name, or rather let's just move on with the same example, x equals to 4. Okay, if I say if x mod 3 equal to 0, I'll say print x. Or let's say I use elif over here and I say x mod 2 equal to 0. I will say print x and then I use else, or let's use one more elif statement, elif x mod let's say 4 equal to 0. Then x plus equal to 1, print x, else print none. It is a very simple program. Now let's see the flow of control in this program. Now we have our number x equals to 4. Okay. Now x, if our 4 mod 3 or 4 divided by 3 is not equal to, let's say the remainder is not equal to 0, then we know that this statement is not going to be executed. We'll move on to the next statement. Okay, now in this elif statement, we know that x mod 2 or 4 mod 2 equal to 0. So our x will get printed over here. After our x is printed over here, our conditional statements will be terminated. This will be null and invalid. Okay, but over here, let's say we have taken 6. Now, technically, 6 mod 3 also equals to 0 and 6 mod 2 also equals to 0. But over here, since this condition has been satisfied, it will not move on to the next statement. Okay, then let's say you take 9. Only this condition would be satisfied. Or let's say you take 28. Then this condition would be satisfied and all of these conditions would be invalid. But let's say you take a prime number. For example, you take 19. Right. Now this is 19 is neither divisible by 3, nor divisible by 2, and not divisible by 4. So neither of these conditions would be executed, and it will move on to the else statement, and our else statement will print none. it is not necessary for you to use the else statement after an elif statement, as you've seen in the previous examples. It is not necessary for you to use the else statement, but the else statement is generally used to, uh, print something if the condition is not satisfied, or tell the user that the condition is not being satisfied. So else is generally used for that. As you can see, you can use multiple elif statements, but only when you have used an if statement. Elif is not independent. Elif is basically else if. For example, this condition is not satisfied, then what? Else if, whatever condition you are stating. After if elif, you have the for loops. For loop. Okay. Now, the syntax for the for loop is for loop variable in range start value, stop value, and occasionally step value. Okay, and then colon, and then you have the for block where you have your set of statements to be executed. Now, in the for loop, what does this part mean? This part basically means or shows or indicates how many times your loop is going to be run. Let's say, for example, I write, I'm going to be taking my loop variable as x. Okay, so for x in range 0, 10. Okay, and I write if x mod 2 equal to 0, print x. Now this is a program for printing all the even numbers from 0 to 10. Okay, so in this portion, x is our loop variable. In range, or how many times the loop is going to be run, is specified by this. This is a start value, which means our loop will start at 0, or the loop will run for the first time at the value 0, and then it will end at 9. The stop value is never included because that will mean that the loop would run 11 times, which is not possible. So stop value is never indicated. What would have happened if I had added a step value over here? Let's say I put over here 2. Then it would skip every other number. For example, it starts at 0, then it will move on to 2, it will move on to 4, it will move on to 6, it will move on to 8, and it will get terminated over there. It won't go on to 9. Or if I add a step value of -1 over here, then the loop will run from 10 to 1. So for, over here, when printing x, you will first get 8, then you will get 4, then you will get 6, then you will get 2, and then you will get 0. Okay, so that is how our for loop is executed. Now, in this, the flow of control would be first first this state part would be executed. Okay, and then after that, this part condition would be checked. If this condition is true, this statement would be executed, and if an else statement and then some statements are given over here, then that if this condition is not satisfied, that would be executed. Coming on to the while loop. Okay, now the while loop is used when you don't have a predefined range or the predefined number of times that you want the loop to run and do. Okay, for example, you want the run to loop forever. Okay, now in the for loop, you cannot get the loop to run indefinite times. The while loop can do that for you. If you just state while true. Okay, now this condition basically states that while true or while true is true. True is always true. So there are any set of statements that you put into this, let's say, block, then any statements that you put into to this block will be executed unless and until you put the jump or loop break statements. Now, what are those? The jump or the loop break statements are basically, if you put break, you have a for loop, and in somewhere in the block you put a break statement. that terminates the loop, or while, let's say, while true, and you execute some statements and then you put a break statement over here. That terminates the loop. Even if it is an indefinite loop, it will terminate it. So if the loop is terminated, it will terminate the loop and then it will move on to executing the next set of statements that you have provided to Python. Then there is a jump statement which is continue. Okay, so while true, you execute some statements and then you put continue. And then you put some more statements inside the block. So if you have a continuous statements in between the statements that you have put inside the block, the loop will never execute these statements, because from the continue it will jump back and move on to the next loop or next number of loop. For example, the loop over here is running infinity times, and then you start from 1 times, 2 times, 3 times, 4 times, and in the first time you hit the continue statement, it will just move on to the second time. These statements will not get executed. So that pretty much sums it up about our loops. Now, there are for else and there are while else statements as well. The loop else statements. Okay. In the loop else statements, what it basically does is the else acts in the same way as it acts for the if conditional statement, which basically means that after our condition in the for loop is satisfied or is not satisfied, it moves on to the else statement and it executes that statement. Okay. Now there are nested for loops and or nested loops, and there are nested conditional statements. For example, I say for I in range 0, 10, for j in range, let's say 0, 5. So first I will take the value, any value between 0 to 9, and after that j will take any value between 0 to 5, right? Which basically means is that this loop will run 5 times for every single loop that will run in this loop. So basically, for one turn in this loop will run 5 times. Okay, that is how these statements will be executed. It is similar for the if conditional statements. You write if x mod 2 equal to 0. Let's say you want to check for a number that is divisible both by 2 and 3. So you write this condition. Either you could do this, mod 2 equal to 0 and x mod 3 equal to 0. Then you could get your statements, or you could get the nested loop and say if x mod 2 equal to 0, if x mod 3 equal to 0, then whatever statement that you want to execute. That is how you can do that as well. So that pretty much sums it up for Python revision 2 part 1. Now we'll move on to some more interesting things. Let's move on to some more interesting stuff. And by interesting stuff, I mean strings, lists, tuples, and dictionaries. Now, I told you what strings already are, so let's discuss some features of a string first. Okay, so, what the hell, bro? Okay, so the first most important property of a string is that it is immutable. By immutable, I mean it is not open to change, any change that it goes through. And by that, I mean that you cannot manipulate a string in any way you want. For example, if you want to replace a character in a string, let's say this is our string. Okay, Anaya. It is the name of a person, right? But let's say you made a typo and you actually want to change it to Ananya, which means you want to replace this A by an N. You can't do that. You can't change it however you want. Now, since you've made it Anaya, it is going to stay Anaya unless and until you use some certain function. Okay, so without functions, it is not possible, and even with a function, it is not possible because the change is not made in the original string. So basically, you can't, let's just say if this X is a string, then you can't do 1, 2, 3, 4 and indexing. You know how to do indexing, right? From the left hand side, it starts with 0, 1, 2, 3, 4 and 5. And from the right hand side, it starts with -1, -2, -3, -4, -5, -6. So if you want to say, let's say, change this character, so you can't exactly be like X index 3 equals to N. You can't do that. Strings are immutable. Secondly, if you want to traverse a string or you want to go through a string character by character, you can do it with the for loop. Okay, let's say we have the same string X equals Anaya, right? If you want to go through this one by one, then you can just do for I in X, or for you can no, you don't need to assign it the string to a variable. You can just directly put your string for I in Anaya and it will go through the string character by character. Okay, now you can concatenate a string, which means have you ever heard that in algebra only like terms can be added and subtracted? For example, if you say you want to add x, 3x plus 2y, so in algebra you can't do it, right? While you can add 3x plus 2x, which is 5x. Right. Similarly, in Python, only two strings can be added to each other. You can't add, let's say you have a na, okay, and you want to add aya to it. So you can't just say plus. If you do this, then this will give you a result of a string which is anaya. But you can't do it in any other way. So if you want to add a list to a string or you want to add a tuple to a string or a dictionary to a string, you cannot do that. That is not possible. Similarly, you can also replicate a string however many times you want by multiplying the string with a scalar quantity. Let's say you say 3 into hello. Okay. Okay. Now this is your string. What it will do is it will give you an output of hello, hello, hello. So you can replicate a string as many times as you want. That is also possible. So that pretty much sums it up about what a string is. Okay, and then there are a lot of functions that you can use to make changes to a string. But the most important thing is that even these functions cannot change the original string that you have made. They make a copy, a shallow copy of the string. Shallow and deep copies are basically what it means is, a shallow copy is a copy that if you make changes to it, it won't affect the original string. While in a deep copy, if you make changes to the, let's say, copied object, it will also make changes to the original object as well. Okay, so let's move on to some functions of a string that are very, very important. When we move on to string functions, I'd also like to mention that you can access a string through slices as well. For example, you want to access only a part of the string, then you can access it through a slice. Let's say, again, we have Anaya. Okay, and you want to access only the first three letters. So you can access it by, let's say you have this string, you put a square bracket next to it and you write 0, 2, 3. Okay, again in a slice there is always a start value, a stop value, and a step value, similar to what we have in the range function in Python. In the for loop. Okay. Now the start value is where you start your slice or whatever. The start value is basically in a slice. The start value is the index at which you start. The stop value is the index at one after the index you stop at. So the stop value is not included, similar to what the range function had in the for loop. And the step value is again, it determines how many times the loop is going to run or how the loop is going to be run. Okay. So let's say I put a start value as 0 and then the stop value as 3. Now we have our index 0, 1, 2, 3. So 1 before the stop value, so we can access this part and our output would be Anaya. Anna. Okay. So that pretty much sums it up for string slices. Slicing can be done to lists as well, to tuples as well, to dictionaries as well. While in dictionaries, you don't actually use a slice, you index, you use keys. So it is pretty much the same for all except dictionaries. Then you move on to string functions. Now, the first string function that you come across in Python is str. Let's say we have a string str. Now I'll explain these to you through examples only. Okay, but first let me write down all these functions. Okay, so first we'll start with the capitalized function. What the capitalized function does is that it only capitalizes the first letter of the statement string or the string that you have inputted. So whenever you use these functions, you always use them with str dot, similar to what you did in the math module. So there is always an whatever string object that you have, that would be placed behind the function and then a period. Okay, so let's start with these one by one. Okay, now let's say you have a string str, okay, which says in all small letters, my name is Devi. Okay, what capitalize will do is that if you use str dot capitalize, it would convert the string to the given output that I am showing. As you can see, apart from the first letter of my sentence, it eliminates all capital letters or converts them into lower case letters. Okay, that is what capitalize does. Then similar to this function, there is another function called title, which is over here. Okay, in this same string, str equals to my name is Devi. In this same string, the difference would be that in this same string, if you use str.title, then the output that we will be getting is every first letter of every word in the statement would be capitalized. That is the difference between str.capitalize and str.title. Okay, so that's two functions. The second is find. Find is basically when you give an indexing value to find, you give a string, you give an indexing value, and according to that, it finds the part of the string that you're talking about. It is similar to slices. That is what the function of find is. Okay, so that is the function of find. Then we start with all the is functions. All these is functions have a basic, let's say, motive to prove whether the subject string is satisfying a condition or not. So if you use is alnum, I have a string where I say str dot is alnum, okay, and my string str is 1, 2, 3, Devi. Okay. Now, in this string, both alphabets and numbers are present. Hence, this would give us a result of true. It would return true. Okay. I'll tell you what return means when we approach the chapter functions. Okay. So, this would return true. Similarly, if a string is only made up of letters, is alpha would prove to be true. While if there is any other character other than a letter in it, spaces are allowed, any other character other than a letter in it, for example a number or a special character, then it would return a false. In is digit, if there is anything other than a digit or a number, it would return false. While any other, if there is only digits, it would return true. In is space, it would basically check whether the string is an empty string or not. So, or if you have a character that you have access from a string and if you want to check whether that character is a space, that's how you would be able to check with the is space function. Is lower checks if the entire string is in lowercase. Is upper checks if the entire string is in uppercase. Now, I want you to know that these functions are not particularly used just for the entire string. When you have access to part of the string through the for loop or through a slice and you are checking that, for example, you have access to part of the loop which has both capital and small letters. Okay, then this would prove to be false, this would also prove to be false. But if it is only has letters and that part we have used in is alpha, that would prove to be true. So this is not only for the entire string object that we have done. You can also use it with parts of that string and you can, it is very actually, let's say, useful when you want to check certain things. So all these is functions, they just return true or false after checking a condition. Okay, then after that you come to lower and upper. When you do str.lower or str.upper, it converts the entire string into lowercase or uppercase respectively when you use these functions. Okay, so if any of my character in the string is lowercase, when you use str.upper, it would be converted to uppercase. For example, let's say rstr equals to Anaya. Okay, now over here, as apart from the first letter, all of these are in lowercase. So if I use str.upper, I would get an all capital string. Okay. Now, I also want you to remember, like before I said, strings are immutable, and many of you must be questioning that we are making changes in the string through these functions. That is not possible. Like I said, these functions, they make a shallow copy of the string and then they make changes to that string, or rather I should say that the changes are not made in the original string or the string that is there. Okay, so you can't exactly change the original string. So that is the function of lower and upper. Starts with and ends with is similar to the is functions. Starts with basically checks that if a string or part of a string starts with the given letter which is given as argument in the brackets. Ends with does the same thing. The only thing that it checks is if the given argument is the ending of that particular string or substring that we are using. Now swap case, I think it's pretty evident with the name itself, but what it does is, if you have a string, let's say str equals to my name is Ari. Okay, now if Ari is my name, now over here this is capital. Swap case will convert this to lower, and Y, A, M, E, I, S, V, I, all these letters would be converted to uppercase. So when you use swap case, your output would be my name is Ari. Okay, that's what swap case does. Moving on to split and partition. Now, the split and partition are two functions that are one of the favorite questions of the board as well, because they ask the difference between the use of split and the use of partition. Now, when you use partition, you get an output of a tuple. A tuple is an object or a number of elements bounded by round brackets. So, the first basic difference is that you get a tuple of 3 elements, which is the substring before the partition substring, the partition substring, and then the substring after the partition of substring. So, if you have a string, let's say, okay, for all you Harry Potter fans out there, let's say we have a string Avada Kedavra. Okay. Now I say that I want to partition this string at K. Okay, and this is our str. Okay, so str dot partition K. Okay, this will give you an output of round bracket string A space. Space will also be included. Okay, so the space will be included, comma K Edavra. Okay, this would be the output for partition. Okay, so the first point, it gives us a tuple as an output, and there are only 3 elements, and it will only change or partition it at the first occurrence of that letter. For example, let's say I partition it at D instead. Rather than K, I partition it at small d. Now the small d occurs over here as well. It occurs over here as well. But in partition, it will only split it at this part. So our output would be somewhat like this. Ava, da, and then remaining string after D. Okay, so this D would be included in our output. Okay, so features of our partition function. First thing, gives us a tuple. Second thing, it gives us the split string at the first occurrence. And third, the partition only gives an output of a tuple of 3 elements. Okay, now let's see what split does. Split gives us the first major difference between split and tuple partition is that split gives us an output in the form of a list. It returns an output in the form of a list. Okay, so let's say I do str dot split D. Okay. Then if I do str dot split D, my output will somewhat be like this. AVA AKE AVRA. I think you can pretty much see the differences yourself. First thing, we get the output in form of a list which is enclosed in square brackets. Second, our split string is not there. The string that we're using to split this our string, that string is not present. And third, it has been split at every occurrence of that letter. Okay, that is what the difference between major differences between split and partition are. The last difference between these two is that if you don't give an argument for the partition, it would raise an error in Python. But if you don't give an argument in the split function, then it will split at the spaces. For example, if I give you str.partition, no argument. Okay, I give you str.partition and no argument. This would give us a big fat error. Okay, but if I use str.split, no argument, I would get a list returning me 2 elements, which is Avada Kedavra. Simple, right? Moving on, we are done with split and partition. Now we move on to count. What the count function does is that the count function checks the occurrence of the substring given as argument. Now, in our same string, str equals Avada Kedavra. Okay, in our same string, we have, let's say we use str.count a. Okay, Python is case sensitive, so it won't count this a, but it will count 1, 2, 3, 4 a's and it will give us the output as 4. Okay, then there is also strip. Strip and rstrip are just parts of strip. The strip function basically strips us of a letter on whatever letter we want to remove. So that is what the strip function does. Strip is basically it removes that letter from the left. Rstrip removes that letter from the right. And strip by default without any argument removes the letter from the right or a space from the right. So that is all about string functions. And moving on, we'll have list functions, tuple functions and dictionary functions.